Question 7. In figure 2, the curve C has equation y equals 6x minus x squared, and the line L has equation y equals 2x. Show that the curve C intersects the x-axis at x equals 0 and x equals 6. So we have our curve C with equation y equals 6x minus x squared. And it cuts the x-axis when y is 0. So we say when y equals 0, then 0 is equal to 6x minus x squared. And the right hand side factorizes, common factor of x, so it's x, rebuild the expression, 6 minus x. And that implies that either x equals 0, this factor's 0, or x equals 6 when this factor's 0. And that completes that part of the question. Part B. Show that the line L intersects the curve at points 0, 0 and 4, 8. So here we're going to solve simultaneously the two equations. So we have y equals 2x for the line and y equals 6x minus x squared for the curve. I call that one equation 1 and that one equation 2. I'm going to substitute for y in equation 2, so I'm going to replace it by 2x. So substitute for y in equation 2. And we get 2x is equal to 6x minus x squared. Taking everything to the right hand side, 0 equals 6x minus x squared minus 2x when it comes across. 6x minus 2x is 4x, so that gives us 4x minus x squared. And factorize the right hand side, common factor of x again, rebuild 4 minus x as the other factor. And from that, it is implied that either x is 0, or if this bracket's 0, x equals 4. Now we just need to find the y coordinates. Well, y is 2 times 0 when x is 0. So y equals 0. And when x is 4, y will be 2 times 4. So y equals 8. And so our 2 points of intersection are 0, 0 and 4, 8 as required. And now for the final part of this question. The region R bounded by the curve C and the line L is shown in figure 2. Use calculus to find the area of R. First we mark on the points of intersection, or at least the x coordinates of the points of intersection, 0 and 4. So this shaded area will be given by an integral between 0 and 4. When we're looking between two curves, it's basically summing an infinite number of little strips like that. And the length of those strips is the difference in the y coordinates of the curve and the line. So we have the integral of the y coordinate of the curve minus the y coordinate of the line. And that integral is with respect to x. So let's replace the y's with terms in x, and we get 0 to 4. The y coordinate of the curve is 6x minus x squared, and the y coordinate of the line is 2x, so we're subtracting 2x. And that integral can be simplified further. We can say it's the integral from 0 to 4. 6x minus 2x is 4x. So it's 4x minus x squared integrated with respect to x. And if we integrate those two terms, integrate 4x, we get 2x squared. Raise the power by 1, divide by the new power. 4 over 2 gives you 2. And if we integrate minus x squared, we get minus x cubed divided by the new power 3. And that's between 4 and 0. So a bracket minus a bracket, substituting the 4 in and then the 0. This is going to be 2 times 4 squared minus 4 cubed over 3. And this one will just be 0 minus 0. 4 squared 16, 2 times 16 is 32. 4 cubed is 64, so this second term is minus 64 over 3. Let's put it on a common denominator of 3. 32 is 96 over 3. And 96 over 3 minus 64 over 3 is 32 over 3. So the answer is 32 over 3 units squared. And that completes question 7.